This is a sample topology that I made in this GNS. So we have here router 1, router 2, router 3. Inside here, I have configured OSPF. Internally, I have configured like here OSPF. Right, so this is OSPF routing domain. This is like a PC where I have configured like no IP routing and IP default gateway, no IP routing and IP default gateway. So it is more like the routed network, like 10.50.1, 10.50.2, 13 subnet here, 23 subnet here. And on router 3, I have given a default route, and that default route is being originated in the OSPF. So this is OSPF basically routing domain. No need to know like a lot about OSPF, just do the basic configuration of this OSPF and that will be sufficient. Now here, what I have done here, I have connected this router number 3 that I have with my actually desktop. So on router number 3, I have connected this GNS3 with my PC actually. So I enabled the Wi-Fi on my PC. Then I went on this device here, all device tab. I selected this cloud button, like I selected this cloud here. So I selected this cloud here, right? So from this all device option, I selected the cloud from there and right click on this cloud, configure and add the network interface card. So Wi-Fi I have added, applied, and then I connected my router with this Wi-Fi. In a way, basically what I did, I connected my physical PC, I connected my laptop with this GNS3 software, right? So that I can now test a few things such as, for example, in the last class, such as, for example, we talked about that syslog, right? So what I can do, I have downloaded this Kiwi syslog server. So I have downloaded this software called Kiwi syslog server. So this is a software that I downloaded on my PC. This is like Kiwi syslog server. This is running on my PC and my PC is connected onto the GNS. What is the IP address of my PC? If I check what is the IP address of my PC, so I can use the command ipconfig. So I can see that the IP address on my Wi-Fi is 172.16.255.197. This is the IP address of my PC Wi-Fi, right? So I can ping from this device, this host number 1, I can ping to this IP because routing and everything is done properly. So here OSPF is running in this internal network. OSPF is running like default route is generated. This router already has the default route pointing towards my PC, right? You can check, you can take a look at on router number 1, you can go on router number 2, and you can go on router number 3, and here you can observe on these routers. You can see on these routers, you can see show IP route. You can see that on this router, on all these routers, we have like OSPF learn routes. I have like default route pointing towards the gateway and all. So in somehow like I connected my this PC with the GNS. Sometimes it works, sometimes it doesn't work. The version that I'm using of this GNS is like 1.5.4. So there, like it is actually possible to connect this GNS3 with PC. You could have also done it like on the EVNG, just like I explained in the last class. Since it was like much more easy to me to use this GNS, so I built this topology on the GNS. Then I configured this Kiwi syslog server. This is the Kiwi syslog server. I downloaded it from the internet, and then I started this syslog services from here. Manage, start the syslog service. So I started the syslog service. That means this my PC is now acting as a syslog server. Right, now what I can do, I can, let's say for example, go to router number 1, I can go to router number 2, I can go to router number 3, and I can just simply say, I can say configure terminal, I can say logging host 172.16.255.197 and logging trap, I can say logging trap and logging trap like 5. Right, so what I did on my PC actually, I configured this on my routers like router 1, router 2, router 3. I configured this command called logging host. Logging host command is basically going to send all the log messages towards the syslog server. In our case, this is our PC. This is my PC that is acting as the syslog server. Additionally, I might need to disable the Windows firewall because Windows firewall is going to block all these incoming connection. So I will go to the Windows firewall and I'm going to turn off the Windows firewall for the moment. So I have either you can allow that Kiwi syslog software on the firewall, or you can just turn off the firewall for the testing purpose. So I did turn off the firewall for the testing purpose. Then I will go to the router number 1, interface loopback 1. If I do, let's say for example, shut. If I do, let's say for example, no shut, right? So the log messages are generated, and you can see that those log messages are displayed onto the software. You can go to the router number 2, interface loopback 1. You can do things such as, for example, shutdown. You can do like no shutdown. Once you do that, you can see those log messages will be displayed on the syslog server. You get the idea. So same thing that we covered in the last class in the packet tracer, you can also do it like the same thing in this GNS software actually, right? So it is completely possible to connect your PC with the GNS, right? So similar to that, now what we are going to do, we are going to configure SNMP protocol, simple network management protocol. We already discussed a little bit about the SNMP. That SNMP is a network management protocol. It is a network management protocol. It is used to manage the network devices that we have in our infrastructure. And it is again an application layer protocol, works on the port number 161 and 162. SNMP has 3 versions, version 1, version 2 and version 3. Version 1, version 2 is called version 2C. There is version 2 and version 2C. Version 2C is much more popular, which is more like a sub-version of the version 2. C stands for community. In version 2C, C stands for community, and it is still the most popularly deployed SNMP version that we have in our market. Right, so SNMP version 1 was the first version of the SNMP. It was an open standard protocol. It was found to be lacking in key areas for certain applications. So there was a need to develop a new version of the SNMP. They created the SNMP version 2, and they created the SNMP version 2C. C stands for community. So version 2C is a sub-version of the SNMP. The key advantage over the previous version in the SNMP version 2C is the use of something called inform messages or inform commands. In version 1, we discussed about this thing in the last class. Let me revise those things. Yeah. So in SNMP, we have 3 things. One is called like SNMP manage the device that we are going to manage via SNMP. Then the second thing that we have is the SNMP agent, right? So the next thing that we have is the SNMP agent, and the last thing that we have is the network management station, the device from where we are going to manage our devices. To manage device could be router, switches, firewall, like these devices, access point, WLCs. These are the managed devices. On these managed devices, SNMP agent piece of software, or we can say SNMP agent module. SNMP agent is more like a software program. It is more like a application that runs on these managed devices. It is an agent that runs on these managed devices. What this agent is going to do, what this SNMP agent is going to do, let's say for example, here we have a router, and on this router we have configured like a lot of things, right? Here we have a router, and on this router we have configured, let's say, a lot of things. What this SNMP agent is going to do, this SNMP agent is going to build a database. It is going to build a database of all the information that it can collect of that particular router. Information such as the interface, information such as the router name, description, uptime, MTU, routing protocol, everything that this SNMP agent can collect from this device, it is going to build a database of that. All this information that it can collect, things such as, for example, MTU, like how many number of interfaces are there, description, router name, uptime, and all that, all the information that it can collect actually, these are what we refer to as the objects. Objects are those things that that can be referred to as the information available onto that particular router. So variety of information of that router, information such as router name, uptime, interface, MTU, all these are what we refer to as the SNMP objects. These are the objects that can be queried by the network management station for a variety of information. Every object is defined by a name, and every object is also given an ID, a number, a numerical value, which is what we refer to as the object ID. Object ID or the name. Object name basically means such as MTU, maximum transmission unit, IF MTU, interface MTU, IF MTU. So this is the name of the object, and this object will have an ID like 1.2. Something like that. There will be an ID of that object that that ID or name we can use to from the network management station to query. It is used to query like about the information on the device. Like let's say you want to check the MTU on the interface of the router. You will go to your network management station. From that network management station, you will open your SNMP monitoring tool, and from there you are going to query for that. You are going to query for that object. You are going to query for that object by either using the name or by using that object ID. So object or object ID, object name or object ID is just the object name is just the name, and object ID is just a number. It is just a numerical value that we can use to get the information from the device. So SNMP agent creates a database of objects, all the objects that can be checked, that can be also configured. SNMP, as simple network management protocol, SNMP, it cannot only like read, but we also have the right level of access like on the SNMP as well. That means we can retrieve the information, and we can also we can also get the information, and we can set the information. We can do both the operations in the SNMP. Certain information can be retrieved, and certain informations can be set by using the SNMP protocol as well. It is not only the management protocol. We can also use the SNMP protocol to set variety of parameters onto the device, such as we can change the host name, we can change like variety of information, we can run a variety of things on the device using the SNMP as well. However, SNMP was never intended to run as a configuration protocol. It was more like it was always built more as a management protocol. So the database that this SNMP agent is going to build, that database is going to be known as the management information base, or MIB. MIBs. What is a MIB? MIB is a collection of object IDs. MIB is a collection of object ID. Management information base, MIB, is a collection of object IDs. Everything that we can monitor, everything that we can configure are known as the objects, and the collection of that object is what we refer to as the management information base, or the MIB. So as soon as we configure SNMP, as soon as we configure SNMP on these managed devices such as router, such as switch, such as firewall, all these devices build a MIB, a management information base, which is a collection of variety of things that we can monitor, that we can configure onto the device. And that database, that MIB, that management information base, is then queried from the network management station to retrieve variety of information, or to basically set some parameters onto the device as well. So SNMP can do both like get and post, get or set, basically get and set, both the operations SNMP can actually perform. So we can not only retrieve the information, but we can also set the information. We can also configure the information in the SNMP as well. So in SNMP version 2, actually, there is a new message referred to as the inform message. So when the network management station, when the NMS sends like a query, like I want to get this information of the router is going to respond with the SNMP trap messages. These trap messages are just delivered on the network management station. These trap message has no acknowledgement mechanism. These trap messages are just sent to the NMS. Now, if the NMS has received that message or not, there is no confirmation about the same. So, but if you are not going to use trap, if you are going to use the inform message is, if the information is being sent in the format of the inform message, that means the NMS, once it receives the inform message, it has to positively acknowledge. And once the router gets the acknowledgement of that inform message, then only the router will assume that this packet was successfully delivered. If not, then the router is going to retransmit that inform message which will include like the error handling. So if the inform message gets dropped, router will come to know about it, and then the router can resend the inform message to the network management station. So in version 2C, we have the use of the inform message instead of using trap messages. Trap messages are simply received by the manager. However, the inform messages are positively acknowledged with a response message. So when the manage the device, when the SNMP manage device sends an inform message, when the NMS received that inform message, the NMS has to positively acknowledge. It has to respond that it has received the inform message. Once the response message is received by the managed device, then it will confirm that the packet was delivered. If not, then it is going to retransmit that inform message again to the NMS, which is going to improve the error handling. Not all the devices are version 2 compliant. Your manager should be downward compatible with the version 1 devices. So you have to see like the support of SNMP version 2, which is like popularly available like almost like everywhere nowadays. So now not all the devices might be version 2C compliant. So your SNMP manager should be, whatever network management software you are using, it must be backward compatible with the SNMP version 1 devices. Your network management station must have the capability to send or receive the trap messages as well as the inform messages. So we have two versions. Version 2C is the most popular version, and C stands for community, which basically gives us the ability to set some kind of like password for the SNMP, so that like not everyone can access the device, or not everyone can retrieve the information from the device, or not everyone can set the information on the device. We can set some sort of like password in the format of this community string. C stands for community string. Community string acts as a password that can be used to either read only or give the read-write access to the user, which is going to query or which is going to set the information using SNMP. Right. So version 2C is still like the most popular version that we have in our environment. Version 3 is also there, which provides like better security, but version 2C still remains the most popular version of the SNMP in your production environment. Right. So to configure the SNMP, what you can do, you can just go on to the device, such as router number 1, and here you can say like SNMP server, and you can say like community, and the community like Cisco@123. This is the password, like read only and read write, and that's pretty much it. That's all the command that you need. So SNMP server community, like this one, and SNMP server community, this one. This is the command that you can configure onto your managed device so that you can enable the SNMP onto that particular device. So the command is like SNMP server community, Cisco@123 for read-only access, Cisco 12345 for example for the read-write access. Whoever has this community string will have the read-write access. Whoever has this community string will have the read-only access of the device. And that is pretty much it. That's all that we have to set. We don't have to set like anything other than that. That is like sufficient. Like enabling this command, like SNMP community and these commands, enabling these commands is like going to enable the SNMP configurations. It is going to enable the SNMP onto these devices. So SNMP server community, Cisco@123 read only, Cisco@123 read write. Now what this device must have done, this device must have like the SNMP agent software. This SNMP agent will run on all these devices. The SNMP agent is going to now build a database of all the information that it can find onto these devices, which we can refer to, which we can like query from our network management station from a centralized point, such as on router 1, show IP interface brief. On router number 2, show IP interface brief. On router number 3, show IP interface brief. On every router, I have configured, for example, a loopback. So what now I can do, since I can now like use these browsers, I can use like these MIB browsers, and from those browsers we can actually gather variety of information from our network management station. So I'm using a similar kind of application on my laptop. The application is from this application is from the manage engine, and this application I'm basically using. This application that I'm using here, it is going to allow us to query variety of information onto the device. So then you have to use a MIB browser The MIB browser basically is a tool that you can actually download from the internet, and then you can run that tool. You can run that tool, and that tool, this is the tool that we have here. So this is like Manage Engine MIB browser. This is a free SNMP management tool. Like you can download it from the internet, and this tool you can use now to query about variety of information from the right. So here you need to now provide the IP address of the device. Here you need to provide the committee strings that we have configured. So IP address of the device, let's say for example, is 13.1.1.1, which is the IP address of router number 1, or maybe router number 3, whatever. Then the port number, then the read strings, Cisco @123, write string, write committee, Cisco @12345. So here, like, you need to provide the IP address of the machine that you want to manage. Here you need to provide the read only string. Here you need to provide the read write string. And then these are the MIBs. These are the standard management information base. These are the MIBs that we can explore for a variety of information. So such as, for example, if you expand this MIB, you can see like RFC, org, DOD, internet, management, MIB, system. So I can expand this. I can actually expand these MIBs, and once I expand these MIBs, I can click on this. And right here it will automatically write down the object ID in the format of name, and right here it will type down the object ID in with the like in the numbered format, and here there is a description of what it is going to do, right? So we have to like expand. These are the MIBs. Either you find this number or the name from the internet, otherwise you can use these browsers, these tools such as Manage Engine MIB browser, and these browsers are going to allow you to expand these variety of MIBs available onto the device. Just click on that, right click and get. It is going to send the information to 13.1.1.1. If on 13.1.1.1, if the reachability is there, from this machine to 13.1.1.1, you will get the information. You will get this information right here. So if you have to click on like right click, you need to say get, and this device is now going to send, this NMS is going to send an SNMP query to 13.1.1.1 to get the what we are trying to get. We are trying to get the system description. SNMP query is received onto this router. This router is going to respond with the SNMP response, SNMP trap message, and that SNMP trap message is going to display the system description right here. Right. So let me quickly cross check once. Do I have the reachability to 13.1.1.1 or not? Because I believe for 13.1.1.1, traffic must be going towards the internet, since it is a public IP, if I'm not wrong. So I am quickly going to check ping 13.1.1.1. On router number 3, ping 172.16.255.197. Okay. From router 1, ping the same thing. Yes, so I'm able to ping from the router to this like 172.16.255.197, which is my PC. But actually, I'm not able to ping from the router. It is because I guess like I have used the public IP 13.1.1. And because of that, the traffic, when I'm trying to ping, the traffic is going towards the internet actually. That could be the reason. So anyway, no problem. What I'm going to do, I'm going to go on router number 3. Here, I'm going to go on router number 3 and configure terminal. On router number 3, I have already configured the SNMP here. So let me go on to the PC. Let me go on to this device and 172.16.255.99. This is the IP address that I have configured on the router 3 interface FA 1 by 1. So from this PC, I am basically going to send the queries to this router number 3, and router number 3 is going to give me the response. So I have set the IP address of the machine. Then here, same thing, Cisco @123. Then here, same thing, Cisco @12345. Then like browse from here what object you want to check, such as for example uptime and all. Right click, get, and it will show you right here. You got the information that your system is up for 0 hours 27 minutes and 13 seconds. You click on system description, click on get button, you will get the description of that particular device. So you are getting this variety of information. You can retrieve this variety of information. This is the system description that I got. So you can how many number of interfaces are there? So click on interface, right click, get. It will show you that there are total 7 interfaces, interface table, entry, like description of every interface. You can get like variety of information from this, like SNMP management like software. You can also, since it is a GNS software, you can also do the packet capture, and hopefully you will be able to see those SNMP messages that are being passed from the device. Yes, easily.
Yeah, so on that, the manage engine, did you add these devices in order to?
Just here. Just like
Okay,
on the host, just configure like, okay, I want to query this host and the read string and the write string. That's it.
Oh, on the left side, the MIP, it's automatically
This one is automatic. This one is automatic. Like these are the standard MIPs that are available on this tool by default. Otherwise, what you need to do, you need to go on the internet. You need to go for that object ID navigator. You need to go to the internet and find out like whatever information you want to check. What is the object ID associated with that particular information? But these tools, like they allow you to, browse the basic information directly by expanding this tree that we have.
So when you get this information about the port or description, interface, uptime, what is that object ID at the bottom side? It's saying 1.3 or dot.
Yeah, this is how, like if I click on any of this, such as for example interface MTU. So this is the object ID right here. This is the object ID. This is the way, I would say, this is the way how each and every object is defined.
Okay.
Right. Okay. So such as for example in the hierarchy, like for example the ISO is at the top. Like ISO means everything. Then from the ISO, then we can have like CPU, we can have like interface, we can have like different sub objects, then the sub object, then the sub object. So that number basically more like a string, using which like it can reach out to that particular, like from the ISO to the CPU or to the interface, then to the description, something like that.
Okay, so each object has its own ID, right?
Yes. Either you need to find it from the internet, from the object ID navigator. Otherwise, these tools basically will allow you to directly browse these object IDs right from here. Like you don't need to go anywhere for that.
Thank you.
And these are just the standard MIPs. Like for example, you need to check the routing table. Just keep browsing and just check the routing table, such as for example, I want to check the forwarding information, TTL and all. So what is the default TTL 255? We should also see the routing table, IP routing table here. So we have the, for example, like routing table entries here. How many destination entries are available in the routing table? It should show you like metric. You can see no data available, no data available. Looks like we are not running what routing protocol we are running. So like again, not all the things might be supported on here, but you can just right click and get information, and it will show you like all the information, all the relative information on here. How many number of packets, for example, like in, out, no records, like drops, all those things can be actually checked right from here. Right, so these are the routes in the routing table: 13.1, 23.3, 172.16.2, 55.99. So we can get like these variety of information right from here. And you can see that every time I'm basically doing the query, SNMP is sending variety of messages. Like you can open these messages. SNMP, Simple Network Management Protocol. This is like version 1 it is using. The committee string is square.123. It is a request to get following information. It is basically a request to get the following information. It is a get request to retrieve the following information. So once these SNMP GET request is sent to the NMS, from the NMS to the like managed device, that managed device SNMP agent is going to respond with the appropriate value of this particular object. Right. So request response, get request, get response, get request response, request response, request response, like that process happens between these SNMP agent and managed device, and that request response mechanism is going to give you variety of information on here. These are the standard MIBs available. Apart of that, like what we can do in the same software, we can click on this button and we can load like other MIBs as well, such as this software has like some MIBs of like different vendors, Oracle database and those things. So such as I can also load up some Cisco MIBs from here. So click on Cisco MIB, open, it will load the Cisco MIBs, and now you can expand the Cisco MIBs and you can get like variety of information from like Cisco specific like software, Cisco specific information that we can get from here as well. Right, so we have the option to, like in this software, we have the option to load these other MIBs, other management information base, other those object IDs and names that we can query from our NMS software. Right, so you can expand, you can explore all these options that are available. This is the use case of the SNMP version 1, version 2. The main use of the SNMP is to retrieve the variety of information from like one centralized point, information that will be useful, the information that will be useful to all these devices. So this is like one of the tools that you can use. Manage Engine MIB browser free tool. This is one of the tools that we can use to retrieve variety of information. How you are connected? In starting we have discussed this, so you can refer to the recording. I have shown you how to connect it. Okay. So you just need to use here the cloud option and then you can connect it. Okay. In the very beginning I talked about it, so you can refer to the recording. Just use the browser, use this cloud, add your Wi-Fi interface in there and just connect it. It might work, might not work. So sometimes it works, sometimes it doesn't. So luckily for me, it worked this time, so I'm able to do all these things from me. Otherwise, you need to use a real router and a real PC. You need to download the software and then you can do the testing from there. Otherwise, you can use the packet tracer. In the packet tracer also, we have these options. Similar to that, similar to this tool, the only problem in this SNMP version 1, version 2, version 2 basically adds some additional like security, such as like company-based passwords, company strings it adds. The problem in both SNMP version 1, version 2 is that all these messages that are passing between these two devices, get request, get response, all these messages are completely like unencrypted. Everything that goes between the device, like it is completely unencrypted. So for example, I asked for subnet mask. It gave me the subnet mask, but the entire information is not in encrypted format. SNMP version 1, version 2, whatever information is passed between the SNMP version 1, version 2, that information is not encrypted. SNMP version 3 adds authentication and encryption capabilities into the SNMP. In SNMP version 3, we have the option to add integrity, authentication, and encryption. We have like three enhancements SNMP version 3 provides over SNMP version 1 and version 2, such as, for example, authentication, such as encryption and message integrity. So we can use algorithms such as MD5 or SHA to ensure that SNMP message was not modified in the transit. So hashing we can do. We can use hashing algorithm to ensure the integrity of the SNMP messages, to make sure that the SNMP messages are not modified in the transit. Authentication, we can use the authentication commands to set a password so that SNMP source can be validated. Whatever SNMP message is sent by the SNMP agent will have some authentication related information. Once the authentication is successful, then only the SNMP agent is going to respond with the proper information. Encryption, basically all the messages that passes between the SNMP agent and the NMS can be encrypted using the algorithms such as DES, triple DES, or AES, so that the messages becomes completely unreadable to the attacker who might try to capture these SNMP messages. So the advantage of the using SNMP version 3 is like it provides additional security over regular SNMP version 1, version 2 messages. However, like configuring SNMP version 3 is a little bit like hectic task. It is a little bit complex as compared to SNMP version 1, version 2. That's why like version 2 is still more popular than version 1 and version 3. If you want to have like additional security for your SNMP messages, then you can go for like this version 3. Other than that, like you will go for mostly SNMP version 1, version 2C basically, not version 1. SNMP version 2C is very easy to configure. Version 3 is going to add these additional security features, but configuring these additional security feature is going to consume like much more time. It is a little bit complex to configure each and every feature rather than configuring a basic 2 commands in SNMP version. We'll see that. Now, not only I can configure this router in such a way that when this router receives the SNMP queries, SNMP GET request, it can send the response. We can also go on this router number 3, for example, and I can set on this router that if certain events occur, then you anyway you are going to send the SNMP messages to the NMS. You do not need to wait for any query message to be received from the network management station. So I can configure this. I can configure this router number 3. I can configure this router number 3 in such a way that it sends the SNMP messages, SNMP traps or SNMP inform messages right away as soon as some changes actually happen. So I can use the command like SNMP server enable and trap, and I can enable like if anything changes, if any change happens related to things such as, for example, BGP, such as, for example, EIGRP or the CPU, then anyway you need to send the SNMP messages. You do not need to wait for the NMS to query first. Or maybe, for example, you get any log message, then immediately send an SNMP trap, SNMP message towards the device. So SNMP server enable trap, such as, for example, you detect any change in the like VRRP, immediately send the log message towards the SNMP software. So we can set this router number 3. We can set on these routers, on these managed devices, we can configure the agent in such a way that agent sends the trap messages or the inform messages right away as soon as the changes related to the particular things happen, instead of waiting for the SNMP queries to be received or GET requests to be received from the manager first. So I can configure like SNMP server enable, trap, and OSPF. OSPF, like OSPF related any errors, LSA related, or just enter OSPF or OSPF version 3. That means like if anything happens, like if any changes happen in the OSPF related things, then immediately generate a SNMP trap, SNMP message, and send it towards the SNMP network management station. It's more like the alarm. It's more like the alerts that can be sent right away as soon as the change is detected. So we can configure things such as like these in SNMP as well. So your NMS, your network management station, must support that. It must support that like those messages. Now let's say, for example, if I say router OSPF 1, if I say shut down, if I on router number 3, if I shut down the router OSPF, as soon as I do the shutdown on the router OSPF, I can see that these messages I got, and as soon as I got these messages, the device will send the SNMP messages right away. It will not wait for any SNMP like a request to be received first. As soon as the changes happen on the OSPF version 3, or like if you get any log message, you will immediately send the SNMP messages towards the server. You need to also configure SNMP server. You need to also configure one thing, SNMP server, actually configure terminal, router, OSPF. You need to tell who is the SNMP server actually. You need to also tell first like who is the SNMP server. SNMP server host. Who is the SNMP server? 172.16.255.197 is your SNMP server. And what is the committee string that we are using? You need to specify here as well. So you are saying that if any changes happen, immediately send the messages to the SNMP server, but you did not specify who is the SNMP server. So we need to tell who is the SNMP server. SNMP server host. Who is the SNMP server? 172.16.255.197 is your SNMP server, and we are going to use Cisco @12345 as the committee string. Then we can either use the command like trap. We can use the command like trap to send the trap messages, or we can use the command inform to send the inform messages towards that particular client, version 2. Something like that. Something like that. So SNMP server host, this is your SNMP server, and send the inform message to the SNMP server, use version 2C, and this is the committee string that we have to use with that particular SNMP server. So you need to specify who is the SNMP server and what is the committee string that we have configured onto that SNMP server. And then we can also specify that instead of sending the trap messages which are not acknowledged, send the inform messages using version 2C and use this committee string for the same. Right, so we can specify the SNMP server information, such as we specified the syslog server information. We can specify like who is the SNMP server, where you need to send the trap messages as soon as like any changes happen onto the device. I'm not sure like if it will send or not, but here now you can see as soon as now the changes happen. Since I said anytime you get any log messages onto the console, immediately send the SNMP trap. Since I said like if you detect any change in the OSPF, immediately send the SNMP traps to the NMS. You can notice here that your device immediately send the inform messages towards that SNMP NMS, network management station. So you can open this inform message. This inform message is about what? This inform message is about some changes that have happened onto the device. So information about the like IP address, something got changed. So that information is being sent to the neighboring device. Then we can open these other inform messages. This might be about some other information. So anytime like any changes happen, those messages will be sent towards the SNMP like NMS, network management station, instead of waiting for the trap messages first. So since this SNMP software does not support any alerts or those things, it did not give like any response in order that. But anyway, like we can also set like you need to send the SNMP traps. You need to send the SNMP traps as soon as like any changes to like OSPF, VRRP, or any log you receive onto the interfaces. Where do you need to send those log messages? What version you are going to use? What committee string you are going to use? You can specify all that information. Now, this is one of the software that we can use. This is like one of the software that we can use. We can use other softwares like this software supports like limited amount of things. Also, it is a free tool, so might not support all the features. So companies might use different tools like for this MIB browsing, or you can use the different tools so that they can get the alerts, they can get the alarms, and so. Right. So yeah, this is like the things that you should know from the SNMP point of view. And if you want to configure like version 3, three things you have to configure. If you want to configure SNMP version 3, you need to configure three things. You need to configure authentication, you need to configure hashing, and you need to configure like encryption. You need to configure like authentication settings, you need to configure like hashing, and you need to configure like encryption, because SNMP version 3 supports like all these three security related features. Configuring version 3 is a little bit complicated. How you have to configure it? First of all, there are like a lot of things that we can do in SNMP version 3, such as SNMP server we can configure this thing called a view. We can configure this thing called a view. View means like what objects users can view, what objects user can, like, check. We can limit, we can configure, we can set, like not everything is accessible to the users. User will have only a view. User will have the access to only these objects that we are going to specify manually. So SNMP server view, and then the name of the view, and then here you need to specify the object ID, or you need to specify the object name, such as I can say ISO included. That means ISO means everything, like the user will have the access, user will have the view, user will have the access, user, whoever is going to query this router using SNMP, will have the access to everything. And then I can say SNMP server view, I can say Cisco, such as for example IFMTU excluded. So this is the name of the object. Either you find this name from the MIB browser, right from here, what is the name for the MTU of the interface, or you can use the object ID navigator, and that object ID navigator, right here it says IFMTU. Right here it says IFMTU. This is the name of the object. Otherwise you could have written down the object ID, and you can say included or excluded. So for example, I can say that whoever has the access of this view, it can check everything except the MTU. Whoever has the access, whoever is associated with this view, can access like everything, but it will not be able to see the operational state. It will not be able to see the operational state of the it says bad UID. I guess like then this one is not supported here. I need to specify the name, something like that. So SNMP server view Cisco, and then the either object ID or object name, then included or excluded. So I said like whoever has the access of this view can see everything, but it will not be able to check the MTU, and it will not be able to check the operational status of the interface. So we can configure this thing called a view in the SNMP as well. View basically is to control what things can be checked and what things cannot be checked by the NMS, network management station. Then once we have configured the view, then we need to configure SNMP server. We need to configure this thing called a group. Let's say for example ABCD. Group like the, let's say for example admin. So you can configure a group like admin. Admin, these are like the users that belong to like the admin group. So then we are configuring here a group called, let's say, admin, and in this group I'm going to define the security that I'm going to use. Are we going to use like version 1 for these users? I'm going to use version 2 for these users, or I'm going to use version 3 for this user. Let's use the version 3 for this user. Basically this is what we are defining. We are defining the security level of these users. Security level version 1, version 2C, and version 3. Version 1 security level, version 2C security level, version 3 security level. In version 1, version 2, we do not have like any security model. The only basic security that can be provided is based on the community string. But in version 3, we have 3 security levels. We have called auth, we have no auth, and we have pre. Auth stands for you will get the authentication, but you will not get the encryption. No auth means you will not get the authentication, you will not get any encryption. And pre means you will get authentication as well as you are going to get the encryption. So I'm going to use version 3 security model pre. Pre stands for like I'm going to get the authentication as well as the encryption capabilities onto the device. SNMP server group admin version 3 pre, and I'm going to define the read access of what view, read access of this view, and the write access of which view, write access of this view. So these users, the users in this group will have the read access of this view and the write access of this view. Users in this group will have the read access of this view and the right access of this view, and they are going to use version 3 priv security model. Additionally, we can also specify the ACL. In that ACL, we can match specific sources that can be used to filter who can query, who cannot query. Such as we have n number of NMS and we want to allow certain NMSs only, then we can match them using the access list if we have configured. No need to do that. So group, it is more like the group of users. So whoever is part of this group admin will have the read access of the Cisco view and the write access of the Cisco view. What is in the Cisco view? They will get access of everything, except they will not be able to check the MTU and they will not be able to check the operational status of the interface. And then what users? SNMP server users. The name of the user, let's say for example I-MEDITA. Then what group it belongs to? It belongs to the group admin. And what security model we are going to use? We are going to use version 3 security model. What password I'm going to use? In version 3, we use like both the things, encryption and authentication. So now we have to define for the authentication, are we going to use MD5 or are we going to use SHA? So if you are going to use SHA, write down SHA. If you are going to use MD5, write down MD5, and then a password that you have to use for the authentication. Then encryption. Encryption I'm going to use either DES, triple DES or AES. So I'm going to use AES string, AES 256-bit I'm going to use for the authentication, encryption, and the password is going to be Cisco, maybe @1CISCO@12345. And again, I can specify the ACL. So here is like the user that I have configured. User I-MEDITA, it belongs to this group. It will use Cisco @123 as the authentication phrase. It will use Cisco @12345 for the encryption. So authentication string and the encryption string we have defined here. Since we use version 3 priv security model, which is going to use both authentication and encryption, we need to define like both of the things here. So configure the view, associate the view with the group, configure the user, make the user part of that group. Now go to your software. Instead of using like version 1 now, you can now go to the settings, edit, you can go to the settings. In the settings, you can now choose, are you going to use version 1, version 2 or version 3? If you are going to use version 3, you need to define the credentials here. You need to define like the credentials here, authentication, password, username, those things. You need to define those settings now here. Right, you need to define the host name 172.16.255.99. You need to define the username. It was I-MEDITA. What security model you are going to use? Auth priv both. Encryption authentication password was Cisco @123. Encryption I'm going to use AES. Unfortunately, I have configured AES 256, but this software only supports AES 128. So quickly I'm going to remove this and I'm going to configure as like AES 128, because this software that I'm using, it does not support like AES 256. So AES 128, and what was the password? It was Cisco @12345. Right, and then apply. Okay. So now like you can go to your software. On your software you can go to the settings, and on the settings you will define. Now this time you are going to use version 3. If you are using version 3, you need to configure the settings. You need to configure SNMP version 3 related information right from here. The same thing that we configured here, we need to configure on here. Now we cannot change these things because we have set it on the settings. Now we can just let's say for example description, I can say get, it will get me the description of the interfaces, but this time I should this time I'm not able to see anything because it is now encrypted using AES. So this is like SNMP related information, but it is completely encrypted, so you will not be able to see what is going on. right? So version 3. MTU, like get, no, you will not be able to get the MTU because you have excluded that MTU in your view. You will not be able to get the MTU. You get everything. You get the MAC address information. You get everything, but you will not be able to get the MTU. Why? Because the user that is trying to basically get the information is not allowed. The user is part of this group, and this group is associated with this view. And as per this view, it is not allowed to check the MTU. So you will not be able to get the MTU. Rest you will be able to get. And all the messages are completely being encrypted, so you will not know, or the attacker will not know what is going on between the devices. Now companies might use different tools. There are dedicated certifications for the SNMP. That is all that we need to know. No need to discuss any further about the SNMP. Moreover, these things, like when we use things such as, for example, DNS Center, we don't even need to configure these things. All we need to do is to just configure. Our DNS Center will be configured as the SNMP NMS. All we need to do is to configure read string and write string on the device. Anyone who has already covered the DNS Center classes must be aware of that. All you need to do is to configure this. Rest of these things will be configured by the DNS Center automatically, and your DNS Center will become, Catalyst Center will become the SNMP network management station, which is going to send the queries, which is going to set variety of things onto the device. All right, so yeah, that's it. That's all about the SNMP. Almost, this is done. This is all that you should know from the SNMP point of view. Version 2 is still like more popular version. We can also go for version 3, where we get like security in much more enhanced way as compared to version 1 and version 2. Similar to this SNMP, we also have one more protocol that I will not say like exactly the same. We have a similar protocol. I would not say that it is exactly the same, but that protocol actually also can be used to analyze a few things on your network device. We have a protocol not exactly similar, but similar to like SNMP that we can use on our devices to again retrieve variety of information, but not specific to these kind of information, not like these kind of information, but the other information like we can actually retrieve variety of like information from the device as well, right? So I would not say exactly similar, but we have a protocol which is kind of similar to SNMP, because it also gives you like this kind of information that we are getting here in our this MIB browser. The protocol that we are talking about here is the NetFlow. We have a similar kind of concept, not exactly similar, but we have this protocol called NetFlow, which is used to analyze different traffic flows going in and out of your router interface. NetFlow is again to analyze the flow of your in your like networking devices. Let's say, for example, in this topology, we have connected a host 1, host 2. They are all able to access to this internet, and they are sending like continuous traffic from here to here, from here to here. Now we want to observe like which machine, for example, is sending more traffic, or we want to analyze these different traffic sent by these machines towards the internet devices. I want to analyze the different like flows being generated from these devices. For that purpose, we can use this this protocol called NetFlow, which is not exactly similar, but like pretty much it gives like similar kind of information. The advantage is that we don't need to do the query, and so as soon as this devices detect like any as soon as these devices basically detect like the different flow traffic, they can export that information automatically. So NetFlow is a protocol that can be used to capture the traffic on ingress and egress. That is the traffic that is coming onto the device and the traffic that is going out of the device. NetFlow collects the traffic based on the flow. A flow is basically a traffic that can be identified by the source IP, destination IP, source port, destination port, source layer 3 protocol type of service, input, interface, and all. So if like there are n number of packets and all those n number of packets have the same source IP, destination IP, source port, destination port, protocol type, class, quality of service marking and all, if all the packets have the same property, then all those packets are considered part of the same flow. A flow of the packet is a set of packets that have the same, like source IP, destination IP, port, all these settings. So if different information is passing from the device, like if this router is passing the information, like if the router is doing telnet, SSH, HTTP, FTP, TFTP, different types of information, this device is passing towards the internet devices. Different types of traffic is received onto this device. I can analyze that traffic and I can send that traffic to our either I can check the information on the box itself, or I can use again a tool. From there we can manage all that information. I can check all that information from there. So NetFlow allows you to capture like the things on the device itself, or we can use the NetFlow to capture the device, capture the flow records onto any external system, such as your desktop machine as well. For that, again, you will require some software. Software such as, for example, this one. Again, I'm using a manage engine software. Again, I'm using this manage engine software. This manage engine software is called like NetFlow Analyzer. This NetFlow Analyzer can analyze the different traffic flow, and you can download this, like it is again a free for 30 days. 30 days are enough. So you can download this NetFlow Analyzer from the again manage engine. It gives like a lot of options, like the main use of this NetFlow Analyzer is to analyze different flow records passing from the particular device. Right. So NetFlow is a protocol. NetFlow is a tool that we can use on the router to analyze the different traffic flow passing from that particular router. NetFlow actually NetFlow has like version I guess version 3, version 5, and version 9. The recent version that we use of the NetFlow is version 9. Some fundamental differences are there between version 5 and 9. But the main version that we use like is the NetFlow version 9. Now we can implement the NetFlow in two ways. Like either we can implement the basic NetFlow, or we can implement a more robust NetFlow using policies and templates, which is what they refer to as the flexible NetFlow somehow. Basic NetFlow, if you want to enable, the very basic NetFlow, if you want to enable, all you need to do is to just go on your router interface, such as on router number 1 or router number 3. On router number 3, whatever traffic is coming in and going out of the interface is FA0/0. I want to analyze all that traffic. So just go on the router number 3. Just go on the router number 3, interface FA0/0, IP flow ingress and IP flow egress. This is the command to enable the NetFlow on this particular device, interface FA0/0. IP flow ingress and IP flow egress. Done. Interface FA0/0, IP flow ingress, IP flow egress. Ingress means incoming, egress means outgoing. So whatever packets now come in or goes out of that device, we can now see, we can now check onto the device. So show IP flow, cache, show IP cache flow, cache and flow command. So here, command is so the command is show IP cache flow. That's it. That's all the command. Like interface FA0/0, flow ingress, flow egress. Done. You can either monitor only incoming and or outgoing, or you can monitor both of the things, like by using the ingress and egress commands. So interface FA0/0, flow ingress, flow egress, and that's it. Just go on the router and use the command show IP cache and flow, and you can see total 5 packets it has received so far, and there is one currently active flow. and this is the latest information. This is the latest packet that we have received like 10 packets on there, and obviously these are OSPF messages. Because OSPF is running between the devices, OSPF messages are sent and received onto the interface FA0/0. So I am able to check that information right here, that as of now total 12 packets on the interface FA0/0 from the source IP to the multicast address are received. Okay, now if I go to the host machine number 1, and if I say, for example, ping 172.16.255.197, yeah, trace route 172.16.255. Oh, I did shut down on the OSPF. If I'm show run pipe section router OSPF, yeah. So router OSPF1, no shut. I did shut down on router number 3. So OSPF was down actually. That's why I was not able to ping from host machine 1. Now let's ping it again. So now what I did on the host machine 1, I tried to ping my PC. On host machine 1, I said like copy running configuration onto the TFTP server. Who is the TFTP server? 172.16.255.197. Basically, I'm generating different traffic flow. It doesn't matter if it gets successful or not. Basically, I'm generating different traffic flow, and I can go on the router 1, I can do the telnet, I can do the SSH, we can do like all those sort of things on here. So if you go on router number 3 now, on router number 3, use the same command again, go on router number 3, use the command show IP cache flow, and you will now see other information as well. You can see information such as you did a ping. So ICMP, you IP other like FA0/0, you can see the information, 27 packets, 3 packets and all. We can see the interface. We can see the information of different flows on this particular device. Right. So we can actually analyze. We can analyze these the traffic that is going on, that is being received onto the device. You can see like the TFTP, you can see the telnet. We can analyze like how many different flows are there onto the device. We can analyze the traffic flow on the particular interface in the incoming and outgoing direction. Also, if this also I can configure this thing called IP flow top talkers. I can configure like top talkers here. Top, how many flows you want to check? I want to check top 3 flows. Let's say, for example, on my network, I want to check like top 3 flows, and I'm going to short them by like packets, or I'm going to short them by bytes, like how much bytes of traffic they have sent, or how much like packets of traffic that they have sent. We have a lot of other commands, like we can match on variety of information as well. Like don't show me like only show me only those top talkers that have the source IP, source address of 10.50.1.0.255.255.255.0. Match basically means like I don't want to check all the top talkers. I want to check the top talkers on the router number 3 that only are from this machine, only from this subnet. Only from this subnet, show me all the top talkers only. So we can specify like plenty of match conditions here. Again, you can explore like we can do the match protocol, TCP, UDP, protocol number. We can use like packet range. We can use the output interface. We can match based on the destination. We can have a lot of options. But we can configure like things such as, for example, like top talkers as well. Now, what I can do, I can go on the host machine number 1, on the from the host machine number 1, I can do again the telnet. I can do again, let's say, for example, ping. I can do, let's say, for example, trace. I can do ping. I can do the trace. I can generate basically different types of packet, and then I can go on the router number. There are like multiple machines available onto this subnet. All those machines are sending and receiving the traffic. I can go on router number 3, IP show IP flow and top talkers. Show flow IP flow top talker. There are no matching flow to show. Show IP flow cache. Show IP cache and show IP flow top talkers is not showing. No, show IP flow top talkers is not showing actually. Show IP flow top talkers are not showing. Did we match on show run pipe section? Show history. Let me do show history. 10.50.1.0 255 255 255.0. Okay, that is correct. Show IP cache and flow. Enter. I can see different type of traffic, but it somehow show IP top talkers. Show IP flow top talkers. It's not showing me the top talker information. Let me do a repeat. Let me see what happens. Yeah, now it's showing. So since the communication was stopped, actually it was not showing me that. But now when I say like show IP flow top talkers, so now since the flow of the traffic is now generated, now initiated, like multiple machines are there, those multiple machines are sending the traffic. The router is basically receiving the flow. Now it will show you like those top talkers right here. Show IP flow top talkers, it says like it is showing like one of 3 top talkers currently in this output. So FA0/0, source IP, destination interface, protocol number, how many traffic type like it is showing me there. Right, so I can go on the router number 1, I can say ping 172.16, 172.16.255.197, source FA1 by 1, repeat. So I can also send the packet from the router number 1 using this IP as the source IP. I can check on the router number 3. It will show me the second one as well. So we can get like plenty of information about like what are the devices in my network that are sending more traffic than the others. We can check like that information from the top talkers as well. So this is like the basic NetFlow. This is the NetFlow that we can configure on the device itself. We can configure like do show run interface FA0/0. We can configure like flow ingress, flow egress, and then that's it. Then we can like show IP cache flow and all those things. Show IP cache flow. We can see all that information right from here. However, like if you don't want to be limited onto the box itself, you want to like export the statistics, you want to export the flow records onto an external system, such as, for example, this one. Such as, for example, this one. Oh, sorry, it was already open. This one. So this is a NetFlow analyzer that I'm using from the manage engine again. This NetFlow analyzer is actually listening on the port number UDP 9996. So what I can do, I can go on this router itself, on this router 3. I can say configure terminal IP flow export. I can export the flows. I can export the flow records towards the destination 172.16 to 55.197. UDP port number is 9996. Enter. IP flow export. I can also specify the source IP. I can also specify the source IP, such as like FA 1 by 1. IP flow export. I can also configure like version NetFlow version 1.15 and 9. These are 3 versions of the NetFlow. Version 9 is like the latest one you can consider. So we can configure like the parameters regarding the export. Like I want to check the information on the device itself, but I also want to check I want to also export the information onto the external systems, external NetFlow collector software. Okay, so here this device is now like this device. Once we have, I guess we have already device, add device. Have we added any device? No, we have not added any device. So 172.16.255.99 is the device. I should not need to actually add the device. It should show me the flows right away actually. Let me add the device then. Since I did not add the device here, let me add the device. I can directly analyze the flows, but it looks like here we need to add the device. So 172.16.255.99 SNMP version 1.2 SSH, but it is for the it is not for actually. It should directly show me the flow records. Actually, not sure why. Yeah, here. Not sure why. Like it's here actually. Like onto here, we should be able to check the flow details from here actually. We don't need to add the device manually. It should automatically, since we are exporting the net flow information, it should automatically be able to get the flow information on here. Maybe like in this software, we need to add this device, but I did not add this device earlier as well. So we can add the device information on here. If you want, like you can add the host name and all those credentials and all. But like ideally, like what do you see actually? Are we receiving the traffic actually? Just wait. Let me go to the secure CLT host one. Yeah, packet is still going on. 172.16.255.197 is the IP correct. 172.16.255.197. It is correct. 172.16.996. That port number is correct. 996 is correct. Unable to retrieve the flows as UTP is blocked by the Windows firewall, but I disabled the Windows firewall. Windows Defender firewall. I have disabled the firewall. Let me actually change advance. I have already disabled the firewall, so this should not actually block here. The port should not get blocked here. Port number is 9996. That is correct. So it should not block actually here. Here it shows the flow information. Here it will show the flow information. Port is correct. It shows the traffic and everything. I tested it in the last class. Anyway, let me configure a different way for this one. So this is like one thing. You can use the command IP flow export destination, and you can configure like the IP address and the port number. You can configure the source, and you can configure like the NetFlow version that you want to use to export the information. Let me, if I remove this, then what happens? It should be able to automatically detect it. Like I should not need to configure these things on there. It should receive that information right from here, right on here actually. Not sure what is happening. Okay, let's use a different method, different mechanism of configuring it. Let me delete this device. Okay, I have deleted this router number 1. Right. Now this is one way. This is like the normal NetFlow. This is the basic NetFlow that we can configure. This is like one way of configuring the NetFlow. This is the very basic NetFlow we can configure. So we can configure like IP flow ingress, egress, IP flow export command, top talkers. We can configure like show IP flow top talkers. We can check those things. This is the basic NetFlow that we have configured. A more robust way to configure the NetFlow is to configure the flexible NetFlow. Flexible NetFlow was created to aid in more complex traffic analysis configuration that is possible with the traditional NetFlow. This is more like the traditional NetFlow. This is like the flexible NetFlow. In the flexible NetFlow, what we can do actually, in the flexible NetFlow, we can configure as per our requirement. We can configure like the policies, like based on which the flows are going to be categorized and then exported towards the exporter software. And in order to configure the flexible NetFlow, we need to configure like 3 things. If you want to configure the flexible NetFlow, you need to configure a total of 3 things actually. One thing that you need to configure is to go on this router number 3. The very first thing that you need to configure is called IP flow, and sorry, not IP flow, flow, not IP flow, flow. You need to configure 3 things: record, monitor, and exporter. Record, monitor, and exporter in the same sequence. First configure the record, then monitor, and then exporter. So IP, first thing like flow, record, name of the record such as for example Cisco, and here we are going to tell what we want to record exactly. What exactly we want to record, what we want to match. We can define now, like we want to match only IPv4, and in IPv4 I only want to match the packet with the source address. I want to match the packet on the destination address. I want to match the packet based on the precedence. Basically, we can define as per our requirement these match conditions. What should we match on? We can match things on the interface, like we can define like all these things. We can define all these match criterias under the flow record. And what information you want to collect? Do you want to collect like the interface counter? You want to collect the IPv4 statistics? You want to collect like the source? You want to collect the destination? You can define like what information you want to collect, what information you want to match on, and what information you want to collect. Those 2 things you are going to define. You can match and collect the information as per your requirement by creating a flow record. Description and everything you can also configure. I have configured that I want to match these things, match the data link MAC address, match like TTL, TOS, protocol number, application name, address, and I want to collect the interface input, output, timestamp, like first, last, everything. Like I have defined the conditions based on which I want to match and collect variety of information. This is what we refer to as the record. This is like the record, flow record, and in the record we have defined like what things we want to match on. Then flow exporter, like here you are going to define like where you want to export the flow information. Here you will define like you want to export the flow, where you want to go, where you are going to export that flow. So flow exporter, let's say this PC, whatever, you want to define the name, and then here you are going to define the things such as for example destination. It is like 172.16.255.197. You can define the source interface, whatever it is. You can define the source interface FA 1/1. You can define the export protocol, NetFlow version 9, that's what is in our content. You can define the UDP port, actually transport UDP, and the port number is 9996. So here basically we are going to define the characteristic of our exporter. We are telling that you need to export all the flows towards here using this IP as the source IP and using the NetFlow version 9 protocol, and the UDP transport you are going to use the port number 9996. This is the exporter. And then we will configure flow monitor, and then we are going to configure this flow monitor, mon, whatever name you want to configure, enter. Here you are going to match your record that we have configured. What was the name of the record that we configured? So whatever the name of the record was there, you need to define that record, and whatever the name of the exporter was there, that you need to define the exporter information. Yeah, that's it. We can also say statistics so that it collects the packet statistics, like based on the size and all that. Okay, done. So this is like the last thing, like the exporter, monitor. So monitor name mon, which is going to refer to our recorder that we have configured and the exporter that we have configured. Now we are going to apply this onto the interface. What was the interface? The interface was, let's say, FA 0 by 0. So I will go on the interface FA 0 by 0. And here I'm going to say IP flow monitor. And the name of the monitor was mon. And then what? Input, enter. Now it will take some time to enable that flow monitor onto that interface. So input, output, we can define here, like all the packets that input, all the packets that out, that go out of the interface, you are going to configure. Right, so you can configure all these things. You can configure, like, all these things like one by one. This is what we refer to as the flexible NetFlow. Flexible in the sense that we can actually match and collect the necessary information as per our requirement. This is more like this is what we refer to as the flexible NetFlow. So flexible NetFlow allows the use and reuse of the configuration component. Flexible NetFlow allows the use of multiple flow monitors on the same traffic. At the same time, we can configure different like monitors. We can configure different monitors. I can configure like one monitor where we have defined a different recorder, different exporter. Then I can configure a second monitor. We can configure like multiple monitors for the traffic. So flexible NetFlow allows the use of multiple flow monitors on the same traffic. At the same time, this means that the multiple different flow policies can be applied for the traffic as the traffic inputs or exits out of the device. Security has been a huge driver in the ability to track all the IP header packet normal size. Flexible NetFlow can dynamically create indivisible cache in the type of flows. Flexible NetFlow can filter ingress traffic destined to a single destination. Basically, the normal NetFlows, they cannot differentiate between different types of ingress traffic, which we can actually see in this flexible NetFlow. So some basic differences are there between the regular NetFlow, the traditional NetFlow, and the flexible NetFlow. The main difference comes in the way we apply these configuration commands to enable the flexible NetFlow onto the device. And once we have done all that, once we have configured all these settings on here, right, you go to the dashboard. See, I did not do anything this time, and I got the information automatically. So I did not do anything. I did not add any device, or I did not do anything actually, but I got the information right away. That's what I was saying earlier. So if I click on this device, I can click on the flow detail. You can see like some traffic is being sent like on here. You can see that a new event has detected, like, so some logs are here as well. So error in processing the flow due to unsupported version of the flow being sent to the device. I guess this doesn't support version 9.
No, you have removed that version 9 from your router.
No, I did not. Version 9 is still running. In the traditional NetFlow, I have configured the version 9. That I removed. Then I configured the flexible NetFlow. There I configured the version 9 again. So looks like I'm not sure if this software is not error in processing the flows for the device IP due to unsupported version of the flow being sent from the device. Then again, I need to find out like which version of this software, like which version of the NetFlow it supports. But anyway, if I go to the inventory, I go to the device, I click on the device, I can see the flow details right from here. I can see, like, for example, different flows that are being received onto that particular device. So host number 1 is still sending the traffic. Host number 1 is done sending the traffic. I'm sending the traffic again. So router number 1, host number 1, they are continuously sending the traffic. That traffic is arriving onto this particular device, and that information I can check right from this dashboard actually. Now interface we can check the application, we can check the source, we can check the destination, we can check based on QoS marking. So again, different things it can match on and show you the information here, right? So on the device we have these variety of interfaces. We can check the information about that interface and different settings of that particular device, right? So we can use this NetFlow. We can use this NetFlow to analyze the traffic flow, different flows of your network. How much traffic is coming in, how much going out, total, maximum. It gives you like an idea like what type of traffic is being sent and out of the interface. I'm not sure like this software that we are using, which version of the software this device supports. If it doesn't support version 9, you can try to change the version to version 5. Then it might, because I got a message here saying that the version that is being used by the device is not supported. So that I can configure. I can configure a different version maybe. And same settings you can apply on the other interface. You want to apply the same NetFlow on this interface, we can apply the same settings. Just go on the router 3, just go on the interface, do show history. Just go on the interface like FA 1/0 and configure the same thing on there as well. IP flow input and IP flow output. So now if this host machine number 2, if it sends some traffic, such as for example like ping 172.16. Or maybe 10.50.1.2, repeat, what is the IP of host machine 1? I believe it is 100. What is the IP? It is 100 actually. .150.1.100. Okay, so ping 10.50.1.100. What is this? On host number 2, I'm not able to ping the gateway. Line protocol somehow is down. Okay, why? On the router number 2, FA 1/0, 1/1, 1/1. Okay, it is 1/1, 1052.1 on host number 2. Oh, I configured the IP on incorrect interface actually. So So I configured the IP on the incorrect interface actually. I configured on host number 2. I configured the IP on interface FA 0/0. However, the IP was on FA 1/1. So I corrected the IP on FA 1/1. And now let's try to ping 10.50.1.2. Should be successful now. 10.50.2.100. Okay, ping 10.50.2.1. It is successful. 10.50.1.100. It is successful. 1.2. What is the host machine 1 IP address? 10.50.1.100. Okay. So what I'm doing here now, from the host machine 2, I'm pinging the host machine number 1, and simultaneously on the host number 1, I'm still pinging to my gateway, to my internet. I'm generating like different types of traffic, different flows, and all those records can now be seen on to this particular collector. So this NetFlow collector that we have, we can, there is one device that it has automatically detected. There are total 3 interfaces. We can click on the device such as router number 3. It will give me the information about the flows that are going on the device. Click on the traffic, right? So it will show you the traffic statistics, average speed and all. You can check on the interface. On the interface level, you can see how much packet is coming in, going out. You can check based on the application, check based on the source, check based on the destination. We have like different settings that we can look on, and based on that we can analyze the traffic flow that are going from the device. So like I said, like we don't need to add the device in the inventory. Like here we could have done it, but we don't need it, because as soon as the records are exported, the device is going to collect that record information, and that record information it will be able to show you here, right? It will be able to show you like what packet, what traffic is basically being sent in and sent out. Again, the level of information that you can see varies on the information that you can see on these softwares. They vary on like vendor to vendor. So for example, this software can show me this much amount of information. Other vendors might show more or less amount of information onto the device, right? So you can toggle in between the charts and all that. You can see the last 10-minute average and all that. So again, variety of options are available, which we can which you can like explore these options onto these software. Again, we don't need to practice on software by software basis. This was just to tell you that how can we configure the NetFlow, right? So in the flexible NetFlow, I configured such as I configured the flow record, I configured the flow exporter, I configured the flow monitor, and then I went under the interface FA 0/0 and what, and then I configured the flow monitor input and output command. I already sent these in the chat. I will also share the document in the group, right? So 3 things you need to configure in this flexible NetFlow option. In the flexible NetFlow, you need to configure like these 3 things. So you can use these different programs. That's what I'm saying. You can use these different programs such as like this NetFlow analyzer to analyze the traffic flow coming in, going out of the interface onto your device. You can use the software for the syslog monitoring. You can use the software for SNMP monitoring. You can use like plenty of other softwares as well, such as, for example, this is a network monitoring software. This is like a network monitoring software, a PRTG. Again, vendor to vendor, these softwares actually vary. So this is a PRTG network monitoring software, which works based on like sensors. So I can go on the device, I can click on the, I can add a device in our network, right? So here I can go to the network infrastructure, and I can, for example, here we will have the option of add a device. Do you see any add device option? So where add group is there, add device. So you can like, for example, you can like right click, you can click on the add device button, and here you need to define the device name, such as like in our case I'm going to add the router number 3. The IP address of the device is 172.16.255.99. 197 is my PC.
Yeah.
Then I can choose a symbol such as, for example, this. Then I can define the SNMP credentials, such as I'm going to use SNMP version 2. The string is like Cisco @12345. Read and write both the access, right? We can configure a lot of things. No need to go through each and everything. Just click on the OK button. So now what this device is, what this is going to do, this in this software, what we have done, actually we have added a device in this software, and now we can add a sensor onto these devices. Sensor basically means, like, for example, I want to do a continuous ping and see, like, I want to get a log as soon as the ping fails. So we can add things such as sensors for that. So click on the add sensor button. These are all the sensors that are available. Like, for example, we can add a sensor to monitor the uptime, downtime, for example, of the device. We can add the sensor for the memory uses and all. We can basically have these sensors that we can add onto the device. Or better, just click on the device and run this auto discovery. It is automatically going to discover what sensors are available, and it is going to add necessary sensors onto the device group automatically. So it is going to like discover that on this router number 3, it is going to basically send those SNMP probes, SNMP messages, ping, trace, all those things, and it will basically add a few sensors onto this device automatically. Sensors such as a ping, sensors such as, like, for example, like see, ping, uptime, interface, these sensors it automatically added. And now I can check like the email alerts. I can check like plenty of things once we have added these sensors on here. So again, this also works based on the SNMP. This also works based on the SNMP. This tool that we have, it also works based on the SNMP. Right. So once this discovery is completed, you will be able to see it is adding the sensors automatically. And once it adds all the sensors, it is going to do continuous ping. It is going to monitor the uptime. It is going to monitor all these interfaces. It is going to monitor the system health. And we can set the alerts, like if something goes down, I should get an email. I should get a, somehow like information about the same. Right. So click on the ping sensor, and you can see that the ping is successful. It is continuously trying to ping onto that particular device. You can see the data. Currently, the traffic flow is already active. So currently I'm already pinging I'm already sending variety of messages. So I can see the statistics, I can see the data and all that. Ping stats I can see from there. So again, we don't need to practice based on the tools, but remember that these tools can help you in monitoring your network in much more better way, such as, for example, system health.
Also free?
No. None of these tools are free. These all are running on the evaluation software. So 30 days evaluation. So I installed it like I installed it like the last day. So you don't need to practice it like that, but just if you want to use these tools, again, your company might use different tools for the same. So you don't need to like practice on these tools such as like NetFlow, such as like, for example, this syslog server. You don't need to like practice these tools from your exam or content point of view. But these tools, like since these all are like monitoring tools, you can actually take the help of these tools to better monitor your network. They are not going to ask in your exam that, okay, configure a software for NetFlow analyzer, configure a PRTG. They don't say that. Right. So for example, it added all these sensors automatically. Click on here. For example, this sensor is to let you know the uptime of this device. So 1 hour 48 minutes. For last 1 hour 48 minutes, this device is completely up. Right. And we can see the live data. We can see the information about last 2 days, 30 days, 365 days, storage data, logs. We can see plenty of things basically of that device. And this software not only supports your traditional router, it supports other devices as well, such as Windows machines. It supports like virtual machines, it supports Linux machines, it supports like VMware printers. No need to worry about those, but we can actually see it shows you like all these things related to the same. Okay, do one thing, send me a link by email. Like if, let's say, for example, I can send an email. I can click I can just right click on here, and I can click on this like send link by email. So when anyone click on that link, it will just open this pop-up window directly. Yeah. So we have like plenty of things available on here. We can add a ticket, resolve a ticket. So these are the monitoring tools that the companies basically use in their production environment. Tools might differ based on the company requirement. Companies might have their own personal tools for the different purposes. But yeah, this is the use of NetFlow. This is the use of SNMP, syslog, span. For example, span technology is the similar thing where we want to monitor a variety of information on there. Right, so NetFlow, flexible NetFlow, 3 things we need to configure: flow record, flow monitor, flow exporter. A sampler, like we can analyze a partial NetFlow rather than analyzing the entire data. We can define the parameters. When matched, then only the flow is going to be considered matched, and then the information will be exported. So we can configure flow records, we can configure the flow monitor, we can configure the flow exporter, we can configure the flow sampler in our NetFlow configurations. Again, no need to go in very detail, just cover as much what we have covered. You can download these applications. You can Once downloaded these applications, you can practice on these applications, but in your exam and all, they're not going to ask you to do anything on these applications. Right, again, one more thing, that these tools again vary. These tools basically like vary. We can configure plenty of things onto these like devices, right? So plenty of options are available on like all these devices. So you can explore the options available on these tools, and if you want, practice based on the same. You need to download these tools from the internet, like NetFlow Analyzer. You can download this PRTG network monitor software. You can download the MIB browser. You can download the Kiwi syslog server. You can download these variety of tools, and these tools will help you in better managing the network. So this part of basic monitoring is now done. One thing that is left is now embedded packet capture, where we don't need to use these, like we don't need to use, this is like this is like packet capture software that we are using here. In iOS XE based devices, it is also possible that we can do the packet capture on the device itself. So that is like embedded packet capture. We can enable the packet capturing on the iOS XE based device, and then we can download the PCAP file on a machine, and then we can analyze it via Wireshark. So that is embedded packet capture, data path packet trace feature, conditional debugs. These things we will talk about tomorrow. Right. So this is one thing that we will talk about tomorrow, and then we will talk about these SLA. SLA we have already covered in our HSRP classes. We are HSRP VRP classes. We'll talk a little bit more about different types of SLA, such as UDP based SLA, TCP based SLA. IP based SLA we have already covered. ISMP based, we will talk about UDP and TCP based SLA. And then the last topic that we will cover, most probably tomorrow itself, is going to be, where is that? No, IPv6 first hop security. IPv6 first hop security features. Here. These are again the security features that are enabled on the switches. So we are going to talk about these features. Rest things such as, for example, NAT is covered in the routing, such as, for example, DHCP covered in the routing. Right. So not everything we need to talk about from the switching content point of view. Whatever things we can configure on the switches, we will talk about only those things. So the only thing that is left now is this embedded packet capture available on the iOS XE devices, some probes, some like SLA, and IPv6 first hop security feature. Again, this is just the theory. This is just the theory that we should know. We will see if we will see a few commands, but from the content point of view, this is just the theory that we should know. Right, a few commands I will show you, such as RA guard, DHCP-v6 guard. We will talk about that. These features will make sense once we have covered the IPv6 actually. So I will assume that you know at least a little bit of the IPv6. If not, then you can just quickly go through the IPv6 topics from your like CCNA or some documentation, so that these features make sense. IPv6 is specifically part of the routing. So once in the routing IPv6 is done, these features will make much more sense. So when the routing classes are done, then you can come back to this recording and then you can refer to these features. But we will finish mostly these additional features by tomorrow itself.